Good day to each and everyone. By the way, my name is Jaskaran Buted, students of AMA Online Education, currently taking up Bachelor of Science in Business Administration, major in Management Information System. And for the completion of Data Communication and Networking 3, which is the course project, the topics which I choose, which I'm going to discuss is Introduction to Scaling Networks, LAN redundancy, and link aggregation. For the introduction to scaling networks, as a business grows, so its due networking requirements. Business rely on the network infrastructure to provide mission-critical services. For the scaling networks, it means to expand the network to an organization to accommodate more devices. For the hierarchical network design, effective network design implementation, it requires a solid understanding of current state of our recommended network models and their ability to scale as the network grows. Hierarchical network model and the Cisco Enterprise network models are considered when designing a network. The need to scale the network is when the business increasingly rely on their network infrastructure to provide mission-critical services. A large business environment with many users, locations, and systems is referred to an enterprise network. An enterprise network must supports the exchange of various types of networks traffic, including data files, emails, IP telephony, and video applications for multiple business units. All enterprise networks must support critical application, converged network traffic, diverse business needs, and lastly, it provides centralized administrative control. So in this figure, it is the step when the networks grows from small to a global enterprise. For the enterprise business devices, users expect enterprise network such as shown in this figure. So outage in the enterprise outage in the enterprise network prevent the business from performing normal activities, which can result in a loss of revenue, customers, data, and opportunities. Enterprise class equipment is designed for reliability with features such as redundant power supplies and failover capabilities. To optimize the bandwidth of an enterprise, the network must be organized so that the traffic stays local and it's not propagated unnecessarily onto the portions of network. Using these three distinct layers, which is the access layer, distribution layer, and core layer. Wherein the access layer, it's provide connectivity for the users, while the distribution layer, it's used to forward traffic from one local network to another. And finally, the core layer is it disperses networks. Each of these layers is designed to meet the specific functions. Even though the hierarchical model has three layers, some smaller enterprises networks might implement two-tier hierarchical design. In two-tier hierarchical design, the core and distribution layers are collapsed into one layer during cost complexity as shown in these figures. For the Cisco Enterprise architecture, it divides the network into functional components while still maintaining the core distribution and access layer. As shown in these figures, the primary Cisco Enterprise modules includes the Enterprise Campus, Enterprise Edge, Service Provider Edge, and the Remote. For the Enterprise Campus, it consists the entire campus infrastructure to include access, distribution, and core layers. The access layer module contains layer 2 or layer 3 switches to provide the required port density. Implementation of VLANs and trunks links to the building distribution layer occurs on here. The distribution layer module aggregates building accessing using layer number 3 devices. So in addition to this module, the enterprise campus can include other sub-module, which is the server farm and data center module and service module. For the enterprise edge, this module extends the enterprise services to remote sites and enable the enterprise to use internet and partner resources. Enterprise edge consists of internet, VPN, WAN modules connecting the enterprise with the service provider's network. And for the service provider edge, all data that enters or exits the enterprise composite network model or the ECNM passes through an edge device. It also provides internet, public switch, telephone network or the PSTN and WAN services. For the failure of domain, a well-designed network not only controls traffic but also limits the size of the failure domain. Failure domain is the area of a network that impacted when a critical device or network service experience a problem. Failure domains often include other smaller failure domains as shown in these figures. For the limiting the size of the failure domain and switch block deployment, limiting the size of failure domains because a failure domain at the core layer of a network can have a potential large impact. The network designer often concentrates on efforts to prevent failures. This effort can greatly increase the cost of the implementing a network, while the switch block deployment, routers or multi-layer switches are usually deployed in pairs, with access layer switches evenly divided between them. So as a result, the failure of a single device does not cause the network to go down. For designing for scalability to support an enterprise network, the network designer must develop a strategy to enable network to be available to scale effectively and easily. Included in the basic network strategy are the following requirements. Use an expandable or modular equipment or cluster devices. Create an IPv4 or IPv6 access address strategy that is hierarchical. And choose as well routers or multi-layer switches to limit the broadcast and filter other undesirable traffic from the network. For planning for redundancy is the critical design feature for most company network. Redundancy is the most important part of the network design to preventing disruption of network services by minimizing the possibility of single point failure. Another method of implementing redundancy is using redundant paths as shown in these figures. For increasing the bandwidth demands continues to grow as users increasingly access video content and migrate to IP phones. In hierarchical network design, some links between access and distribution switches might need to process a greater amount of traffic than other link aggregation. Ethernet channel is a form of link aggregation used in switch network as shown in these figures. When expanding the access layer, the network must be designed to be able to expand the network access to individual and devices as needed. To communicate wirelessly, end devices require a wireless NIC that incorporates a radio transmitter, receiver, and the required software driver to make it operational. Additionally, a wireless network or a wireless access point or the AP is required for users to connect as shown in this figure. For the fine-tuning routing protocols, routing protocol configuration is usually rather straightforward. However, to take full advantage of a protocol feature set, it is often necessary to modify the configuration. For the single area OSPF, The link state routing protocols as the open shortest path or the OSPF, as shown in this figure. It works well for larger hierarchical network where fast convergence is important. OSPF is a popular link state routing protocol that can be fine-tuned in many ways. While the multi-area OSPF support a two-layer hierarchical design, or the multi-area OSPF, as shown in this figure. And for the EIGRP protocol, dependent modules, or the PDM, is another popular routing protocol for larger networks. Is the EIGRP. Cisco developed EIGRP as a proprietary distance vector routing protocol with enhanced capabilities. So in this figure is an example uses multiple tables to manage the routing process using the protocol dependent modules, or the PDM. For switch platforms, when designing a network, it is important to select the proper hardware to meet the current network requirements, as well as to allow the network growth. There are 5 categories of switches for enterprise networks, as shown in this figure. So first is the campus LAN. Next is the cloud managed switches, the data center switches, service provider switches, and lastly the virtual networking. And for the switch platform, when selecting the switch network, the administrator must determine the switch factors. It includes the fixed configuration, the modular configuration, and the stackable configuration. These are the common business consideration when selecting switch equipment, which is the cost, port density, power, reliability, port speed, frame buffers, and scalability. For the port density of a switch refers to the number of ports available on a single switch, as is shown in this figure. While the forwarding rates, it's defined the processing capabilities of a switch by rating how much data of a switch can process per second. Switch product lines are classified by forwarding rates. And for the power over Ethernet, it allows the switch to deliver power to the device over the existing Ethernet cabling. These figures can be used by IP phones and some wireless access point, as shown in this first figure. So the relative new Cisco Catalyst 2960C and 3560C series compact switches support power over Ethernet pass-through, as shown in the second figure. While the multi-layer switching are typically deployed in the core and distribution layers of an organization's switch network, multi-layer routing tables support a few routing protocols and forward IP packets at rate close at that of layer 2 forwarding. As shown in this figure, the Catalyst 2960 switch illustrates the migration to a pure layer 3 environment. And for the router requirements, it is like switches. Routers can play a role in the access, distribution, and core layer of the network. Routers play also a critical role in networking by interconnecting multiple sites within an enterprise network, providing redundant paths and connecting ISPs on the internet. Routers can also act as a translator between the different media types and protocol. So the router's beneficial function is that it provides broadcast containment, it connects remote location, group user logically by application or department, and provide an enhanced security. As a network grows, it is important as well to select the proper routers to meet its requirements. As is shown in this figure, there are 3 categories of router, wherein these 3 categories are the branch router, network edge routers, and lastly, the service provider routers. And for the router hardware, also come in many factors as shown in this figure. Router can also be categorized as fixed configuration or modular. With the fixed configuration, the desired router interfaces are built in. While managing the iOS files and licensing, routers and switches all come with Cisco iOS software. Network administrators are responsible in managing these devices. So for routers, beginning with Cisco iOS software release 15.0, Cisco modified the process to enable new technologies within the iOS feature sets as shown in this figure. For the inbound versus outbound management, regardless of the Cisco iOS network, regardless of the Cisco iOS network device being implemented, there are two methods for connecting a PC to the network device for configuration and monitoring tasks. This method includes the outbound and the inbound management, as shown in this figure. Outbound management is used for initial configuration only, or when a network connection is unavailable, while the inbound management is used to monitor and make configuration changes to a network device or to a network connection. For the basic router CLI commands, it includes the copy running config startup config, erase startup config, as well as the basic router show commands, which includes the show IP protocols, show IP root, and lastly the show IP OSPF neighbor. And for the basic router show commands, the show commands related as well to interfaces, wherein these show commands are show interfaces, show IP interfaces, show IP interface brief, show protocols, and show CDP neighbors. Basic switch configuration includes the host name for identification, password for security, and assignment of IP addresses for connectivity. Inbound access requires the switch to have an IP address. For this example, it shows the command enter to enable the switch, or you can enter as well EN for enable the switch. And for the show running config, it shows the results of the configuration commands that were entered for this example. For the basic switch shows command, this includes the show port security interface, show port security address, show interfaces, and show MAC address table. Next topics which I'm going to discuss is about the LAN redundancy. So, network redundancy assures network reliability by using multiple physical links between devices, provide redundant path. So, multiple paths needs to be managed so that the layer 2 loops are not created. The best paths are chosen and alternate path is immediately available should a primary path fail. Redundancy at OSI layer 1 and 2. So, the STP or the spanning tree provides the mechanism to have redundant links at layer 2 while avoiding the potential for loop and MAC address database instability. The three-tier hierarchical network design that uses core distribution and access layer with redundant attempts to eliminate a single point of failure on the network. So in this figure, it shows the redundant at OSI layer 1 and 2, wherein PC1 is communicating with PC4 over the redundant network topology. When the network connection between the switch 1 and switch 2 is restored, the path is then adjusted to the route traffic directly from switch 2 to switch 4 to get the PC4. The OSI layer 1 redundancy is illustrated using multiple links and devices, but more than just physical planning is required to complete the network setup. So, for the redundancy to work in a systematic way, The use of OSI Layer 2 protocols such as STP is also required. These these are the primary issues for Layer 2, wherein the MAC database instability, broadcast storm, and multiple frame transmission. Issues with Layer 1 redundancy, MAC database instability. In this figure, the PC1 sends out a broadcast from the broadcast frame to S2. So S2 received the broadcast frame and the fast internet 11. When S2 received the broadcast frame, it updates its MAC address table to record the PC1 is available on the port to fast Ethernet 11. When S2 received the broadcast frame from S3 and S1, the MAC address table is updated again, this time with the last entry received from other two switches. While the broadcast storm, it shows the final resulting during step 6 on this broadcast storm, wherein in step 6, when the network is fully saturated with the broadcast traffic that is looping between the switches, new traffic is discarded by the switch because it is unable to process. Which show in this figure, S2 is now discarding additional frames. For the duplicate unicast frames, the following steps demonstrate the duplicate unicast frames issues. It shows a snapshot during the step 5 and 6, wherein in this for the step 5, S3 also has an entry in its MAC address table for PC4. So it forwards the unicast frame outrank 3 to S1. And for the step 6, the switch 1 receives the duplicate frame and forward the frame out to PC4. Spanning tree algorithm, or for the introduction, in this figure, all switches have STP enabled. Spanning tree algorithm port roles. When the STA has determined which paths are most desirable relative to each switch, it's assigned port roles to the participating switch ports. The port roles describe their relation in the network to the root bridge and whether they are allowed to forward the traffic. As shown in this figure, for the root bridge, every spanning tree instance switch LAN or broadcast domain has a switch designated as the root bridge. The root bridge serves as reference point for all spanning tree calculation to determine which redundant paths to be blocked. And for the path cost, as a newer or a fast Ethernet technologies enter the marketplace, the path cost value can change and accommodate the different speeds available. The path cost is equal to the sum of all the ports costs along the path to the root bridge, as shown in this figure. And for the 802.1D BPDU frame format, the spanning tree algorithm depends on the exchange of BPDUs to determine a root bridge. As shown in this table, the BPDU frame contains 12 distinct fields that convey path and priority information to be used and to determine the root bridge and paths to the root bridge. And the BPDU propagation and process, each switch in the broadcast domain initially assumes that it is the root bridge for the spanning tree instant. So the BPDU frames sent contain the BID of the local switch as the root ID. So by default, the BPDU frames are sent every 2 seconds after a switch is booted. That is the default value of the hello timer specified in the BPDU frames is 2 seconds. Extended system, the extended system ID, the bridge ID is used to determine the root bridge of the network. The BID or the bid field of the BPDU frame contains 3 separate fields. These fields are the bridge priority, extended system ID, and the MAC address. And for the LAN redundancy configuration, I will be using the activity number 2 for this LAN redundancy configuration. And for the third and last topic is for the link aggregation. Link aggregation is the ability to create one logical link using multiple physical links between two devices. This provides load sharing among the physical links. Link aggregation is the process of using multiple redundant links as one logical link in order to take advantage of underutilized links to increase bandwidth. For the introduction to link aggregation, for the redundant link with STP. In this figure, traffic from several link, usually 100 or 100 or 1000 MBs, aggregates on the access switch and must be sent to distribution switches. Due to the traffic aggregation, more demand of links with higher bandwidth capacity must be available between the access and distribution switches. And for the advantage of Ethernet topology as shown in this figure, the most configuration tasks can be done on the Ethernet channel interface instead of its individual port, ensuring configuration consistency throughout the links. Ethernet power also provide redundancy because the overall link is seen as a one logical connections. For the Ethernet channel operation and the implementation of restriction, Ethernet channel can be implemented by grouping multiple physical ports into one or more logical Ethernet links. Each Ethernet has a logical port channel interface as shown in this figure. A configuration is applied to the port channel interfaces that affects all physical interfaces that are assigned to the interface. For the port aggregation protocol, Ethernet channel using one of two protocols or the PAGP or LACP can be formed through the negotiation. With similar characteristics, these protocols allows ports to form a channel through dynamic negotiation with adjoining switches. As shown in this figure, the PGIP is a Cisco proprietary protocol that aids in the automatic creation of Ethernet channel links, while the LACP or the Link Aggregation Control Protocol, it is a part of IEE specification or the 802.3AD that allows several physical ports to be bundled to form a single logical channel as shown in this figure. For configuring the Ethernet channel, the following guidelines and restrictions are useful for configuring it. The first one is Ethernet channel support, VLAN maps, and the range of the VLAN. For configuring the interfaces, configuring Ethernet channel with LACP is based on two steps, wherein these two steps can be it specify the interfaces that compose the Ethernet channel group using the interface range. And the next configuration is the channel group identifier mode active. So on the first figure, it shows the topology that is used, configuration, verification, and troubleshootings examples in these sections. While in the next example in here, the Ethernet is configured as a trunk interface with allowed VLANs specified. Interface port channel 1 is configured as trunk with allowed VLANs 1, 2, and 20. For verifying the Ethernet channels, there are a number of commands to verify an Ethernet configuration. These commands includes the show interface port channel, show Ethernet channel summary, show Ethernet channel port channel, and lastly the show interfaces Ethernet channel. I will be showing you a link aggregation configuration which I submit also for the laboratory of this course project, which the laboratory exercise number 3.